Hi, I'm Matt Cope with the Electrochemical Innovation Lab at University College London. I'm going to talk to you briefly about my work on digital disassembly. Digital disassembly is a non-destructive X-ray CT method where we rigorously, mathematically, examine the structure of the jelly roll and look at how it affects the performance of the cell. Now, the first key step is to find the jelly roll. So we find the contours between the different layers, something like this. Now with those, we can perform a simple coordinate system transform and map this into cylindrical coordinates, and we end up with a plot that looks something like this. What's really useful about this plot is it allows us to pick out imperfections a little bit more easily. Like for instance, right here and here, we can see that there is significant deformation in the jelly roll, which corresponds to here and here. Now what's really useful about this is very predictive about eventual cell deformation. So if we look at these figures here where we show more unrolled plots as the cell is aged, we can see that deformations tend to form in those spots, which is very useful. Something else that's really great about this method is it's quite quick. The underpinning technologies, CT scans, aren't exactly known for being overly fast. However, we've been able to generate these results in scans that were generated in as much as, or as little as 5 seconds. And lastly, something we've found recently, in a more detailed analysis, is that it's highly correlative. The performance of the jelly roll, or the deformation of the jelly roll, correlates really well to the capacity fit of the cell, and I'll show you what I mean in a second. If we look at a plot like this, we've actually superimposed two of these plots on top of each other, and just track the strain in the jelly roll. So how much it's moved from, let's say, 0 to 50 cycles. The blue and red arrows indicate inward and outward deformations respectively. And what we see is if we plot this over, let's say, the first 300 cycles of the cell, or the cell's lifetime, we see that eventually, let's say between 100 and 250 cycles, there is a significant amount of deformation taking place, especially in the inner jelly roll. And we consider this jelly roll collapse. And what we see is if we plot that against the capacity fade, there's actually a significant amount of capacity fade that takes place during that same period of time. Looks like that's the knee point of this cell. Now we've also seen this for other cells. This wasn't just a fluke. Here's one that starts at 200 cycles. And again, we see the knee point, kind of the end of the first life of that cell, take place right around then. And most importantly, we've seen baseline data that suggests that if there isn't a significant amount of deformation, there won't be a significant amount of capacity fade. So this is really excellent. In summary, digital disassembly is predictive, digital disassembly is quick, and digital disassembly is correlative. If you have any questions or comments, please contact myself or Professor Paul Shearing, who's in charge of this work. Thank you for your time.